Hi, welcome back to our Honors Geometry video playlist. Today we're going to take a look at rectangles. 6.4, so I've got a few definitions there just to start off, that a rectangle is just a parallelogram with four right angles. So the opposite sides are still parallel, the opposite sides are still congruent, the diagonals still bisect each other, the consecutive angles are still supplementary. Those properties still apply. But we have a new set of properties here where if you have a rectangle, the new property is that those diagonals not only bisect each other, but they're now congruent. So taking a look at our rectangle ABCD, if AC is 2x plus 13 and DB is 4x minus 1, I want you to find DB. Well, I know that those two things are equal. These two parts are equal, so I can just set those equal and solve for x. And then here x should be 7. But just like before, the same properties from before apply. So AE and EC are also going to be equal. And then you get what? 2x 18, x would be 9, but then I need to plug that back in. This would be 30. And then if I were to plug in 7 for x on A, we get 27. Here's one part that I think throws us off still, at least what I've noticed. BAC and DAC. BAC is the angle from B to A to C. It's this angle right here. DAC is this angle right here, because if I trace from D to A to C, this is the angle. It's the middle letter in the name of the angle. That's where you want that angle to be marked. So I've got my two angles, 2x plus 4, 3x plus 1. But what do I know about the angles in a rectangle? They've got to be 90 degrees. So if they've got to be 90 degrees, I know these two things must add up to 90. So 5x plus 5 equals 90. And I could solve from there. I'm going to ask you to try C and D on your own. Pause the video, try those, and then unpause and check your work. Here x should be 17. 85, that's 1535, that's 17. 30, 51, 52. This would be 11x minus 26 I'm sorry. Erase that. Try that again. What do we got? ABD. ABD CDB, these are equal. So we got 3x, 36, x is 12, 48, 53. All right, so example 2 here. What do we have? We have a bunch of triangles. I have 4 triangles. That's really the key here. There's 1, 2, 3, 4. They told me 1 was 37. So I know that these must be complementary. That makes a 90. So I got 53. And then what I can do is I can use a ton of, linear pairs, alternate interiors, like angle 4 and angle 1 are alternate interior. So angle 4 has got to be 37 degrees. And I can use that to find my missing parts. Please check out the rest of these in just a second, but please pause the video, try to fill these out, and then unpause and check your work. All right, so 4 is 37, 1 was 37, 2 is 53, and then this is going to be 37, 5 is going to have to be 53, Four is going to have to be 37, 3 is going to have to be 37. So that's 74 between these two, which leaves me with 6 is 106. And then angle 7, 53, this would have to be 53. And then this is going to be 106, that's going to have to be 74 degrees. The key here, how did I do that? Is because these are congruent diagonals. These are actually congruent triangles on the left and right, congruent triangles on the top and bottom. But how did I know that this was 37 degrees? Well, if these are congruent diagonals that are also bisected, then what I have here is an isosceles triangle. This is isosceles, this is isosceles, these two are isosceles, and those base angles must be congruent, so that helps out a lot. All right, on example 3, I'm going to ask you to try those two on your own. What you're trying to prove is that you have 4 right angles by showing that the slopes are opposite reciprocals. What you're trying to prove here is that the diagonals are congruent. Prove that the two diagonals have the same length. Check your work on the PDF answer key that I post on Classroom, please.